In this video, we're going to talk about balancing simple equations. Okay, so here we are given a chemical equation that is representing a reaction. We have water, and under certain circumstances, you could make it form H2 and O2 gas. When we write equations to talk about what reaction is happening, we need to make sure we balance the equation. Now, what the heck does balancing the equation mean? The balancing equations, so balancing equations, that's what we're going to do. And that means that the number of atoms, the number of types of atoms on each side has to be equal to each other. So let's just remind ourselves, what would this H2O look like? I have H attached to O attached to H. And it's giving me an HH and an OO. And we'll color code it. My O's, I'm going to make purple. And my H's, I'm going to make, well, let's make them blue. Okay, this is not implying a Lewis structure at all. If I were drawing a Lewis structure, it would look like this. Okay, I'm just showing you, hey, I have two oxygen atoms and they are attached, they are bonded to each other. So maybe like we'll really show that they're bonded to each other. Okay, so I want to balance the equation. Now I'm going to make a little table, reactants and products. On the reactant side, I have the atoms of hydrogen and the atoms of oxygen. I better have them on the product side too. Otherwise, I made a mistake. If I don't have both atoms on both sides, something's up. Okay, so in the reactant, how many hydrogens do I have? H2O. How many hydrogens do you have in H2O? Well, you have, the subscript tells you you have 2. And you can see when you draw it out that you have 2. So right now I have 2 H's. And in the product, how many H's do I have? I have one H2 molecule, but how many H's do I have? How many H atoms? I have 1, 2 H atoms. So I should specify that this is the number of atoms, right? A representation of them. Okay, so how many O's do I have on the reactant side? I have 1 O on the reactant side. And how many O's do I have on the product side? I have 2 of them. And we can see that in that representation that we have 2 of them. Okay, so let's see if they're balanced. I have 2 in the reactants, the H's, and 2 in the products. Yay, check. Then I go to my oxygens. I have 1 in the reactant and 2 in the products. So obviously those are not equal to each other, so I need to balance them. I have 2 O's in the product side, 2 O's in the product side, so I need to I need another O here. I need another O, but can I just add another O? I can just pop an O on there. I'm not allowed to do that. I actually have to add oxygen in the form of water because that's on the only reactant I have. So to add the O, I brought in another water molecule. I brought in another water molecule, and now you can see, yay, I have 2 O's, but they just had to come along with it because I can only add the molecules that I'm given. Not allowed to change subscripts. We know why. But I can change coefficients. I'm allowed to change coefficients. Okay, so that's exactly what I did. I said, I'm going to add an extra water to get that extra O. Now let's check. So now I have 2 O's. Yay. But what happened to the number of hydrogens I have? So I have 2 hydrogens in front, which means I have 2 sets of these. 1, 2, 3, 4. Now I have 4 H's. I have 4 H's. And I just want to write that out. If you had it written like this, you could say, oh, I have 2 times 2 of those to give me 4. So you can visualize it by drawing it out if you need to, or you can see I have 2 waters, whatever makes sense for your brain. So now I have 4 hydrogens, and I need to double check and see if it's balanced. And we already know it's not, right? I have 4 now, but I only have 2 here. I have 4. I need 2 more. So I'm going to add another HH. I need to add another HH on this side. to add another HH on this side. How do I do that? How do I show it with a coefficient? So all I need to do is add that 2 in front. I have one H2 molecule, two H2 molecules. I express that I have two of them by putting a 2 in front. I express that I have two of the water molecules, two of these, 1, 2, by putting this 2 in front. This 1, 2 is that 2 in front. Okay, so that is my balanced equation. My balanced equation looks like this. 2H2O to give two H2s and should have double checked it, but it was 4 when I was done, plus O2. And if I wanted to, I could double check it again just to make sure I have the right number, but I do. Okay, check, double check. That's what I like to say. Now, next one, what are you going to do? So I don't know if you like the little visual. If you want to, you can make a visual. I have 1 phosphorus. Chlorine comes in a set of 2. This P, Cl3. I have 3 of them. And make chlorine green, 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 green. And you can tell right away, reactants to products, that they're not balanced, right? You can see the 3 chlorines on one side and you can see 2 chlorines on the left, but the phosphoruses look balanced. So, you know, phosphorus is good, chlorine's not. We know things are going to change. So let's just write our little column. So I have reactants and I have products and I have phosphorus and I have chlorine and I need the number of atoms on each side to be the same. Reactant side, I have 1. Product side for phosphorus, I have 1. Chlorine, I have 2. And in the products, I have 3 chlorines. The only way for them to add up, so let's, you can't, I'm not going to add a half of something. So I'm just going to start adding more chlorines because the one on the left has 3. So I'm going to add more chlorines. That's 4. Well, now that I'm at 4, that's not going to work. But I can see this one has 3 and that one has 2. If I multiply 3 times 2, that's going to give me 6. 6 is going to be my number. So if I add 3 in front to give me 3 chlorines, and I have 2 of the PCl3s, PCl3, see how I have 2 there? Doop, doop, boop. So now on the left side, I have 6 chlorines. I have 6 chlorines. 1, 2, 3, 4, 5, 6, just counting them up. And on the right side, 1, 2, 3, 4, 5, 6. I have 6. Phosphorus on the left, I have 1 still. Phosphorus on the right, now I have 2. So because I have 2 on the right, I need to put a 2 in front of the 1 on the left, and then it's going to be balanced. What does that look like here? Well, I need 2 phosphoruses, 3 chlorines, and 2 PCl3s. That's 2 of these PCl3s. Okay, so let's do another one. And in the next one, I'm not going to draw out the image, but if you like the images, they really help you, do it. Go nuts. Okay. So now I have PCl2 and PCl5. So reactants, products, right? And atom, I have phosphorus and chlorine again, but this time I have 2 and I have 5. So reactants, phosphorus, I have 1 in the reactant side, and I have 1 in the product side. Chlorine, I have 2 chlorine atoms, and on the right side, I have 5. So there's no way for me to make 2 into 5 I'm gonna have to multiply one side by 2 and the other side by 5 to get me 10 on each side. So I'm gonna multiply by 5 chlorines and I'm gonna multiply by 2 to give me my 10 chlorines. If you're visualizing that, I have 5 Cl2s, 5 sets of those. 5 sets of those will give me 10. And then 2 sets of the Cl5 will give me 10. So I have 10 Cls on both sides, 10 and 10. Now phosphorus on the reactant side has only 1, but now I had to use a 2 in front to get to the 10, so I have 2 phosphoruses. To make it balanced, now I need to multiply by 2 in the front, put a coefficient of 2, now I have 2, and that is going to be my balanced equation. Okay, so I kind of want to just show you, how do I do this in my head when I have 2? You see you have 2 times only 1 phosphorus, that gives me 2 Ps, and 2 times the 5, 2 times 5 chlorines gives me 10 chlorine atoms. Okay, let's do the last one. So this one is a little bit trickier because we have oxygen in 2 different spots. So I always avoid when I have something in 1 spot and then 2 spots, if the other thing is only in 1, like carbon's only in 1, and hydrogen is only in 1 location, I'm going to balance those first. I'm going to balance the atom that's in a bunch of places last. Okay, so oxygen I'm going to do last. It really doesn't matter which one we pick. Reactants. Whoops, I did not mean to do that. I accidentally took a snapshot. Just no, delete. So I have reactants and products. And I have carbon and hydrogen and oxygen. So on the left, I have 1 carbon. On the right, I have 1 carbon. On the left, I have 4 hydrogens. On the right, I have 2 hydrogens. On the left, I have 2 O's. And on the right, I have 3 O's. Okay, so carbon is already good. Check, check. So let's go to hydrogen. I can see I have 2 here and 4 here. So I'm going to need to throw a 2 in front of here. 2 water molecules. So 2 times 2 will give me 4. If you still can't see it, just draw out the water. 2 of them. Whoa, those are really ugly H's. But 2 water molecules will give me 4 H's. So I have 4 H's in the product side from my 2 waters. And now that I put 2 out in front, now that you have 2 waters, you also have 2 times 1 O, 2 O's. So, oops, why did I put a, oh, sorry. So, okay, now let's count up our O's. So now I have 2 O's from this. Actually, let's give O a different color. Yellow, yellow, yellow. And that'll make it easy for me. So that way I can find it easily. So now I have 2 O's from this side, but I also have 2 from here. So I have 4 O's. And on the left side, I only have 2. Well, is it easy to make O2 into 4 O's? All I need to do is bring in a second O2 molecule. Picturing I have an O and an O. And then I'm bringing in my second OO. 2 of them, that will give me my 4 oxygens. Now let's check. So feels like we're done. 1, 1, yes. 4, 4, yes. 4, 4, yes. Yay. So my balanced reaction has a 1 in front of the CH4, a 2 in front of the O2, a 1 and a 2. And you don't have to, that 1 is understood. So you could actually not put it there at all. So I could definitely not put it there. And I don't need anything in front of this CO2. Again, I could put a 1, but I don't need to. And I have a 2 in front of the water. I will say, I never really thought about it before, but it's kind of nice when you highlight the atom, like, ooh, that's nice, because I can see it in two spots. That way it makes it just easier for you to see and count them up. You don't have to do it, but that made it kind of nice. Okay, I will see you in the next video.